In this video, we are going to discuss about the optical biosensor. So, by the end of this topic, the students will be able to understand and identify the primary components, and they can able to differentiate between the surface plasmon surface and the fiber optic transduction mechanisms. They can able to analyze the biochemical pathways. Also, they can able to evaluate the specific engineering trade function with the specific cost. So here is the outline of our lecture. So we will start with the general introduction to the optical biosensor and the basic architecture. Then we can divide into specific transduction types, focusing on the surface plasmon resonance and fiber optic systems. Following that, we can cover the absorbance and the luminance based methodologies. So this outline their distinct advantages and disadvantages, and finally look at the recent developments and the future clinical applications in the final part. So, an optical biosensor is an integrated and analytical device that consists of actually biological recognition equipment, physical detector element, and a signal transducer element, which is directly connected with both these components. And this biological recognition components is actually used as a protein target, that is such a specialized bioreceptor. So, these systems are frequently coupled with the microfluidic networks. So this microfluidic integration allows us to effectively introduce the target analyte, and it dynamically separates the background molecules from the active matrix. Here the types of the optical biosensor. So surface plasmon resonance is a physical phenomenon where the conduction electrons in the thin gold film are excited into collective harmonic oscillation. So this excitation occurs precisely on the surface of the metal, and also this generation of the surface plasma will cause a sharp drop in the intensity of the light at the specified angle that we call it as resonance angle. And this to successfully capture and measure the target ligand and the analyte interaction, one of the interacting molecules will be permanently immobilized from the active sensor surface, so that this SPR chip will have to achieve their molecular immobilization. So by looking at this instrumentation diagram, here you can see the resulting real-time sensogram curve on the right side. So you can see how the system tracks the interaction through distant phases. That is, it establishes a stable baseline, displays a sharp curve during the association phase. As the analyte binds to the final functional layer, it reaches a steady equilibrium state and undergoes a dissociation drops. So then finally it experiences a regeneration phase to return to the first baseline. So this entire shift in the reflection angle will track the exact concentration and binding consonants. And the second major operational category is the fiber optic biosensor. So these are the analytical devices where the flexible fiber optic waveguide serves as the central transduction elements, and these sensors will be manufactured using the high purity silica glass fibers. Then this internal property, that is environment or the biological change, will act directly on the fiber core, which will cause the measurable modulation of the transmitted light signal in the form of frequency. And the extrinsic fiber sensor, so that is the input fiber channels light away from the source and delivers it to the external backforce. So the region where the actual reaction is taking place, depending on the specific clinical target, this external modulation may be constructed and it will be given to the chemical mechanisms. And the absorption based optical sensors and the luminance based optical sensors. So luminance is normally defined as the light emission that is not primarily generated from the heat. It is a direct instead it is directly cold light output resulting from high energetic reactions. So in the case of the medical diagnosis and the food safety, this approach is highly utilized for the rapid detection of bacterial contamination. So to perform this, we introduce the Firefly luciferase. And the advantages, um, when moving on to optical platform, first these devices can be made especially very small. This will allow them to fit into ultra low volume microfluidic channels and also catalogs. Second, the optical fibers themselves will be more flexible and making this ideal for integration into wireless devices. So finally these fibers will be made for the glass or medical grade plastics, and also they can be able to possess the excellent biocompatibility. Thank you.